Hello and welcome to the Wireless Innovations Forum special seminar today, webinar, Beyond the Tower. And we're very fortunate to have Dennis Roberson and William Webb here. We're going to talk a little bit about the D2D revolution and what's going on and discuss topics that they've covered very wonderfully in their new book. So to begin with, I'll provide just a one-slide introduction to the Wireless Innovation Forum. I think it's probably familiar to many of you who are on this webinar, but in case it's not, we are a standards development organization organized as a trade association model, a nonprofit. And our mission is advancing technologies supporting innovative utilization of spectrum and the development of wireless communication systems, including essential and critical communication systems. One of our important aspects is we have a broad and diverse and global membership. We're an international organization, and we have companies from all over the supply chain, including component, subsystem, and equipment vendors. We have service providers, research organizations, universities, academic institutions, and government users and regulators. This gives us a very wide perspective on creating standards. So what do we do? Our primary thing that we do well is we translate the rules that regulators come up with into working systems that can interoperate. Sometimes we do technical reports to inform government regulators on certain aspects that they may be considering, but we're primarily a technical organization. We take a set of rules once they're defined, and we turn them into working systems. We have a consensus-driven process, and all members get one vote. It doesn't matter whether you're a small company or a very large company. There are a lot of competing interests, as you can imagine, but once the regulators put together a set of rules, we come into the scene and we make them consensus-driven for the entire industry. So if you want to contact us, we're at wirelessinnovation.org. Be happy to discuss further membership opportunities or what it is we do. So with that, I'm going to introduce our moderator and CTO, Andy Clegg, who is going to oversee a lot of the presentation here. And we're going to begin with some overview slides, but primarily we will discuss all of this D2D revolution. And just in terms of logistics, if you have a question, please type it in to the questions box. We will monitor it and we will provide it to the presenters. And as we have time, we will perhaps be able to answer some in line as you ask them. But if not, we will take them as many as we can at the end and try to answer any additional questions you may have. So with that, it's Beyond the Tower, available on Amazon, and here to talk to us today. So thank you for being here, and good luck on the webinar.
All right, thanks, John. Hopefully you can hear me okay and see me.
Yes.
Okay, good. So yeah, we are very fortunate to have with us today the two authors of the book Beyond the Tower, Satellite D2D Revolution. They have a lot of fascinating things to say in this book. The book is a collection of a lot of really useful data about the current constellations and efforts to launch direct-to-device and direct-to-cell service. And it ranges from the data about the constellations themselves, the engineering analysis of providing D2D from space. They even, for the nerds among you, they even have information and appendices about orbits and link budgets. But they also talk extensively about the business models that may or may not work and what their views are of how this is all going to pan out. And that's what they're here to speak about today. So great book, a great effort from both of them. So the speakers are Dennis Roberson, who is currently the founder, president, and CEO of Roberson and Associates. Dennis has been around quite a while. He's got 40 years of experience in the industry. I've known him for probably 15 or 20 of those. He was the vice provost for research and a research professor in computer science and law at the Illinois Institute of Technology. He was executive VP and CTO at Motorola. He's had executive roles at IBM, Digital Equipment Corporation, AT&T, and NCR, I guess formerly National Cash Register, years and years ago. He is the chair of the External Advisory Board for Spectrum X, which is an NSF-funded spectrum center. Chairman of the board of Marconi Society. He's been FCC TAC chair and member for many years. He's also been a CSMAC, a Commerce Spectrum Management Advisory Committee member for quite a while. He's on the board of many technology-based companies, more than 50 publications. He's got a BS in EE and physics from Washington State University and an MS in EE from Stanford. So Dennis is quite an expert in this field. There are very few people who are as expert as Dennis is, but we just happen to have the other one with us today, and that is William Webb. He is currently the CEO of Comcisive. He was a co-founder of Newell, which was a technology company that eventually developed the standards on which IoT connectivity for 4G and 5G operates, NB-IoT. He was the CEO of Weightless Special Interest Group that was developing standards related to the Newell technology for unlicensed spectrum. He has been a director at Ofcom, which, for those of you who don't know, is the UK's regulatory agency for telecommunications. He's been involved in multiple consultancies in the UK, from hardware, computer simulation, propagation modeling, spectrum management, the whole gamut. He has been in strategic management at Motorola. I think he and Dennis overlap there or something. They'll tell us a little bit about that. President of the Institution of Engineering and Technology. And in fact, I discovered he was the youngest ever president of that very large European organization. He is on Spectrum X Advisory Board. He's a writing machine. He has 22 books, greater than 100 papers, and also 18 patents. He's the fellow of the Royal Academy of Engineering, the IEEE and IET, and he has a PhD from the University of Southampton in the UK. So obviously we have two very experienced people here. And I'm going to break the presentation here just for a second because I'm going to turn my mic and camera off so you all don't have to look at me the whole time, and then I will turn it over. But Dennis and William, while I'm doing that, go ahead and say hello.
Yes, greeting and good morning to all of you. Good afternoon to those in Europe. Good evening if you're even further around the globe, and good night to some of you perhaps in Asia. So we look forward to the opportunity to share the findings of our book and actually to have a conversation. We've allowed, Andy and John have been gracious to allow a considerable amount of time, and as you choose to expend it with us, we'll look forward to interacting with you. I'll let William provide his welcome and then we'll dive in.
Thank you, Dennis. And yes, great to be here. Thank you very much for inviting me. Very much looking forward to this. It certainly sparks a lot of interest. It's a very topical subject. And so delighted to be here presenting. Looking forward to some good questions. And I'll hand it back to Dennis, who's going to take over for the first part of the presentation.
Yes, we've divided it almost exactly in half, and I'll, in a certain way, provide the introductory and foundational materials, and William will then dig into some of the findings based on the observations that we make in the front end. I will have to give one more piece that I actually expected Andy or John to mention, but Roberson and Associates is a member of Win Forum, and that's a delight for us, and looking forward to being much more active member as we move forward. So with that, we'll move on to the first content slide. And this sets out the background for the book. And it has a much longer background that I won't dig into, but William and I have written a recent book last year, and actually been involved in various writing projects over the years. But this one really struck us as important. It's very topical in that many people, not just us, are asking the question, where does D2D fit? Will D2D end up replacing terrestrial cellular? Will it come alongside? Or will it be an abject failure? And all three are potentials, and William in the end will describe our findings on where that comes down. But on this slide, we captured just some of the press to illustrate how topical this subject is. Certainly SpaceX, with their recent IPO, has garnered a lot of focus in this area and other areas as well. But recently they're talking to Charter, and there's some speculation. Will SpaceX and Starlink end up acquiring a terrestrial property? Will they come alongside? How does that all fit? Of course, others have been in the game. T-Mobile, working with Starlink, have had an opportunity to share there, and there's some contention maybe SpaceX would even acquire T-Mobile or Deutsche Telekom in an even broader scoped activity. There's, on the other side, the carriers, wandering through the chart, the carriers are not so sure that they like a relationship with SpaceX and Starlink, and in fact, even T-Mobile, who have had the relationship for some time now with Starlink, are a little questioning whether that relationship is going to be a boon or a bane for them. And finally, we're really looking at where all of this comes together and how it will ultimately shake out. But there's a lot that's going on in this space, and that's the point of this slide. And we had determined, actually over Christmas time, that it was appropriate for us to dig in, both for our own understanding and then to share that with all of you and with all of those who purchased the book. So next slide. Just a bit on the current situation, and I somewhat introduced this with the notion of T-Mobile working with Starlink, as they have for a period of time. But this really got started with the iPhone deciding, and the Apple people deciding that they wanted to have the extraterrestrial connectivity, particularly for rural environments, so that globally you could always be connected with an Apple phone. And my company, my consulting company, had the good pleasure of working with Apple and with Globalstar, a long-term client of Roberson and Associates, to produce that capability. And through that capability, given that the 1/4 of the connected phones out there are Apple, you could approximate that 1/4 of the global consumer population have the opportunity, although it's not quite available in every country in the world, but a large percentage of the world, and over half of the US population, since Apple occupies more than half of the pockets with cell phones these days, have this capability of connecting to space when they no longer have the ability to connect in the terrestrial domain. So that's one of the opening points. Given that it's already there, what's the big deal about D2D? It's already available. And we'll talk a bit about that, because the current capability, as those of you who have tried your emergency SOS service would know, it is at this point a very limited service, basically a pager kind of service, taking the old term, but a text-based service at this point. There are others that are coming on, and coming on fast in the Western world, and we'll talk about the global world a couple slides down. But Amazon Leo has, and Amazon more generally, has jumped into the game and are challenging SpaceX in a fast follower kind of mode, and looking to leverage their significant reach in the retail world through the space connection. And then there is AST SpaceMobile, that is providing an alternative and completely different approach to the topic, with gigantic satellites, with the goal of offering service that is akin to the service that you have on a terrestrial basis with your cell phone today. And others have jumped in and noted here Vodafone, AT&T, and Verizon. And many have noted this, along with the point of the consortium of the 3 American providers, as defensive moves, because it's not clear that they want SpaceX and Starlink to end up with a monopoly position. So supporting an alternative, which AST represents a strong alternative, is viewed as very much in their interest. And there are many other mobile network operators around the globe that have aligned themselves with AST SpaceMobile. Next slide. There's a significant history that is involved here, and what is pictured is the original Iridium phone. And having been with Motorola through that era, this is a very familiar one. In fact, I still possess one of these devices. But the history is not so good in this area. Iridium, as many of you, if not all of you, know, went bankrupt and then was resurrected by the military, and recently was acquired by Rocket Labs, trying to parallel the SpaceX and Starlink connectivity. OneWeb jumped in and with a perspective that they would do it better with more satellites and provide the connectivity around the globe, and ultimately they also headed for bankruptcy, were resurrected by the US or excuse me, the UK government, and subsequently were acquired by Eutelsat, the French satellite provider. Globalstar was also started mostly by Qualcomm some long years ago, but it fell on hard times, and billionaire Jay Monroe picked it up for something of a song. But now Apple has jumped in and it certainly supported it significantly, and finally it was acquired by Amazon in recent days as an early entry for Amazon Leo before they get all of their satellites in place. Beyond Globalstar and for that matter OneWeb, there have been quite a number of consolidating connections between the companies. I already mentioned the Iridium by Rocket Labs, Inmarsat by Viasat, Intelsat by SES, and then Link and Omnispace merged together, but facilitated by SES, and there are more. But it's a consolidating environment right now. The shakeout is producing stronger players, even as the leading player is clearly SpaceX and Starlink. Next slide. One of the key challenges in all of this is the ability to actually get the satellites into space. And right now it is a limitation. It turns out there are quite a large number of satellite launch capabilities, but most of them are for very small satellites or single satellite launches, and are therefore quite expensive. The leader, as most of this audience would know, has been SpaceX, with their extensive fleet, the Falcon set of products, and more recently the Starship that they are driving forward. But they're not alone. There's also the United Launch Alliance, which is the combine of Lockheed Martin and Boeing, the classical space launch folks. But there are others. The Rocket Labs I've mentioned, the Blue Origin, which is sadly pictured below, a very significant competitor to the very large launch vehicle that Starlink, or excuse me, that SpaceX has with their Starship. But the New Glenn rocket recently exploded and really put the Blue Origin folks into a difficult place. Around the globe, there are other launch capabilities, and we'll talk more about China in particular, but they have an increasingly significant launch capability. However, when you move into the capacity that they have, as you can see in the chart, it's roughly a tenth of the capacity that exists in the United States, again, dominated by SpaceX. And there are the others. Russia historically was in the game, but the war, I think, has worn them out in their ability to really be a competitor. Europe has a significant capability with the Ariane launch capability, but really very, very few launches per year. And then the rest of the world is very limited, Japan and India with much smaller rockets. So that's the environment. And it is a limiting environment. Right now, there are more satellites that would like to be launched than there is capacity to launch them. Once the Starship is in place and hopefully the New Glenn from Blue Origin rights itself, then there will be significant capacity. But right now, this is one of the limiting features in putting the constellations in space. Next slide. And I've sort of alluded to this with the last slide, but the world is being partitioned in this area. The US is clearly dominated, as you saw with the launch capability there, and again with SpaceX, but with Amazon LEO and AST SpaceMobile coming along with their capabilities, and they all have global aspirations to provide capabilities. Not everyone in the world would like to have the US dominate the space, and Europe has its own entry. IRIS is built on OneWeb and others, but is a distant player in the domain, given how few satellites they've actually put in space and the challenges there. Russia has aspirations. They would like to do things, but again, right now they're encumbered by their war efforts. And that moves us to China. China is attempting to mirror the capabilities in the US and have aspirationally very large constellations that would be nearly peer constellations to Starlink, and would basically their aspiration is to cover the world with an alternative to the US domination. The Gulf countries, and William has been involved with some of their activities, have had aspirations to move into this area, but again, they're somewhat encumbered and really don't have the necessary expertise and background to be the major player that they perhaps would like to be, which leaves the global South. And there are a lot of players, all of South America, all of Africa, virtually Australia and the like, that are in need of connectivity somewhere. And whether they fall into the Chinese or the US sphere of influence is probably one of the big questions to be answered as time goes on. But it is a partitioning of the world that we're seeing, and that's something to be very aware of. Next slide. Starlink, I've been mentioning right along, and most of you know Starlink for its broadband service, the non-D2D service as applied to cell phones, but the familiar flat antenna that you see in the lower left has been and continues to be ubiquitous around the world. And you see the growth year by year that has accrued, and basically doubling every year the number of access points that are out there. The challenge, of course, for them is in the lower right, and that is that while they are dramatically increasing the number of installations, the price that they're able to charge is continuing to fall. The map in the upper right shows where the concentration is of those Starlink activities, and they've done reasonably well in connectivity, in connecting with the global South that I referenced in the last slide. So they have aspirations to make their D2D service parallel their broadband service, and they have a strong leg up in being able to do that. Next slide. There's a beautiful picture. This is actually a park in the UK that sadly I was not familiar with, but this is Catcraig, and it's a beautiful national park there. There have been proposals to provide cell service in the park, and what you see in the second bullet is the World Heritage Site is not the place for a cell phone, is the determination. or telephone tower, I should say. And this is part of the opportunity that exists for satellites, because satellites don't obscure the natural beauty of the environment, and from an economic standpoint as well. There are not that many users in the various national parks and deserts, and certainly not in the ocean. There just isn't the capability. So that provides a huge opportunity for satellites, and one that, per the last bullet, even provides the opportunity for some of the mobile network operators to eliminate non-productive cell towers that they put up to meet some regulatory requirement, but that actually are not economical. So it's an interesting part of the equation, and really is the justification for D2D because of this opportunity. Next slide. And here we get into some tables, and there's a lot of information here, and we'll make the slides available, or even better, buy the book, and you can have this information. But the illustration on this slide is that in covering where people live, things have gotten very, very good, as you can see with the 99% down, 99% plus coverage for the populated areas of the planet. What that tends to mask, because that's the number that people quote, is the actual land mass coverage, where people go, not where they live, but where they go, where they travel, where they need service. And as you can see, scanning across the second row, UK does pretty well, not so well in the US with its large geographic reach, very not well with Canada, with the Northland, with the so low population, and then Australia is similar with the outback. There's just not much coverage there. The major roads tend to be covered, but it is variable as you get away from the US and the European countries. We use UK as sort of a catch-all for the European countries. The policies to get the coverage, each country has taken a push at achieving the geographic coverage, and the areas to be covered is the final row, which the national park that you just saw, beautiful national park. But there are different areas in each of these countries and in each of the countries in the world where cell coverage is lacking. Some would say that's a good thing because of the peace and tranquility, but in terms of emergency service needs, it's not a good thing. So that's where the direct-to-device really comes in and is very strong. Next slide. And this is my final slide. We'll transition from here to William, but covering the standards, the 3GPP folks in particular, also the ITUR, have been very actively involved in the non-terrestrial network space. And from release 17 in 2022, it started the drum roll of providing the standards necessary to cover the non-terrestrial network and the integration, importantly, as you go from left to right, the integration between the non-terrestrial and the terrestrial networks has been increasing with standardization. We're coming up on release 20. The work is underway there to really allow the harmonization to be very, very strong, and on into even release 21 as we have the full integration in line with the 6G capability. So much work has been done in this space from a standardization, and this is probably one of the key distinctions from those failed efforts that I hit several slides ago, when Iridium and OneWeb and Globalstar and so on were putting up their capabilities and failing to really achieve the goals that they had. But now we are positioned to really have that capability with significant strength. And now I'll pass things to William, who will take a lot of the materials that I've put forth as a foundation and transform those into our findings and our perspective on the future, our forecast of where the road leads. Take it away, William.
Thank you very much, Dennis. Could I have the next slide, please? So I'm going to present a few slides now that have a lot of numbers in them. I have to say, it's really difficult to do the numbers in this area. It's difficult because, first of all, a lot of these companies just don't publish the data. So if you try and find out exactly what the capacity of a Starlink satellite is, you'll find that's very difficult. Starlink won't tell you directly. You can get estimates, but you can't get the actual data. Unlike, say, a terrestrial cell tower, where you can find all that out directly from the standards or similar. So it's difficult to get the information. And then plans are changing constantly. For example, the number of satellites. So you'll see AST, I've got down there 168 satellites initially. I heard just a day or two ago, they're now scaling that back to 43 initially. So all these numbers are in a constant state of flux, and they're all rather uncertain. So I think take these numbers as reasonable estimates, but absolutely not as what the final numbers are going to be. But I think they're still going to be helpful in building some conclusions around this overall market space. So this slide is looking at how much it costs to actually get the initial constellation in orbit. And don't forget, of course, that these satellites only last typically 4 or 5 years once they're up there. So you've got to constantly replenish that constellation once you've got it up. So this is just the starting point. And essentially, you've got two costs. You've got the costs of building the satellite, and then you've got the cost of launching it. And if you take a look at each of the columns, you can see we've got Starlink. Satellite costs 1 to 2 million, something like that. Relatively low launch costs because, of course, they've got their own internal launch capability with SpaceX. A large constellation size, something like 7,500 initially, with authorization to go up to 42,000, and with aspirations potentially for even more than that, depending on filings and so on. So you can multiply the two numbers together, 7,500 times the cost of launch and the unit cost, and you get to something in the region of at least $15 billion. Run the same numbers for Amazon. Their satellites are about the same, but their launch costs are much higher. And that's a reflection of the fact they've got to go to the commercial market at the moment, pay others to launch them into space. And so even though their predicted constellation size is only half as big as that of Starlink, their costs are higher, something like 22 billion. As Dennis mentioned, AST have got a completely different approach, much fewer satellites. As you can see, an end number of about 240, 250, something like that. But each satellite is huge and much more complex, and that's reflected in the costs. They haven't split out their satellite and launch costs. So the numbers we've got are something like 21 to 23 million for the combined to build and launch of a satellite. But you can see that's a lot more. That's an order of magnitude more than SpaceX, for example. But then they've got many fewer satellites. The net result of that is that their overall costs are lower, about $3.5 billion around that. There's also costs for the ground segment. So these are the Earth stations that are used to backhaul the satellites. Much harder to get to grips with. SpaceX have already got a pretty dense ground network that they're using for the existing Starlink services. Amazon don't. There's some discussion that perhaps they might leverage the AWS sites they've got around the world as a place to put Earth stations. And AST are looking for partners in that space. We haven't costed that ground segment, but that's clearly going to have some cost to it. There's also a spectrum cost. Now, for most of these operators, their initial starting point was that they were going to use or to work with a mobile operator, an MNO, and therefore they wouldn't have to acquire any spectrum. They would simply partner with, in the case of Starlink, T-Mobile, and so on. But there would then probably be some revenue share, and that's not discussed typically. But you can imagine that essentially that the mobile operators would take some kind of revenue from their subscribers, but not necessarily pass all that on to the satellite operator. They would keep some because of the use of the spectrum, because of all the other things they're doing in terms of subscriber management. And we've assumed roughly that something like 50% of the revenue that comes in to a mobile operator would find its way to a satellite operator. But of course, if those operators do want to buy spectrum, then that's suddenly a different ballgame. And we've seen SpaceX buying the EchoStar spectrum for $20 billion. So that's US only spectrum, costing more than their entire constellation of satellites to get them built and launched. So clearly you could absolutely dwarf these costs with spectrum acquisition costs if you started doing that globally and at scale, potentially. We haven't seen too much of that yet, but Amazon Leo bought Globalstar almost certainly primarily for its spectrum access, and we may see a few other acquisitions in this space. Next slide, please. Okay, so the other side of the business case is the revenues, and that's also very uncertain with a whole load of different approaches going on here. So Apple don't charge for the service, at least not directly. Indirectly, you'd assume it's bundled into the price of an iPhone. They had indicated when they first launched in 2022 that they would only provide it free for 2 years, but that free period has continued on afterwards. So it looks like they're going to continue that indefinitely. So essentially, the model there is one of hardware subsidy, paying for that. T-Mobile have got a couple of approaches. One is that they provide satellite for free for their very top bundles. I think the aim is there to encourage subscribers to move up through the bundles, to buy more expensive bundles that come with a number of things like greater data packages and so on, but also the satellite access. But you can pay around about $15 a month to add it on to a lower tier package if you want to do so. So that's an interesting initial price point, $15 a month. The next two are a couple of non-cellular examples, but nevertheless examples of global satellite systems. An entity called Bullet doesn't exist anymore, had a niche rugged terminal. It would charge between $5 and $30 a month for that. But Garmin, which does exist, has a standalone sort of communicator device, $15 to $65 a month, depending on the functionality and the global coverage that you want in that space. AT&T, at the time we wrote this, it was pretty unclear. I think they've now said that they might charge something in the region of $10 to $15 a month for this service. So some initial price points that we're starting to see emerge, but it's unclear how many people will pay those price points. Is this a tiny minority of subscribers, or is this 50% or 100%? And secondly, whether those price points will stick, or whether they're initial high pricing that will then start to slide over time as they go for broader marketplace. Again, very, very difficult to assess that. Very hard to understand what this service is worth and to what extent it's worth it to a large number of people. Next slide, please. So we can start to pull these numbers together in a very approximate manner. And what I've got here is essentially the costs over a 10-year period for each of those three operators, looking at the CapEx costs. So I'm ignoring here OpEx costs associated with salaries and buildings and so on. I'm ignoring any spectrum costs that might occur. So this is really just the cost of getting that initial constellation up there and then replenishing it over a 10-year period as the satellites lifetime expire and deorbit. And compared to that, I've also got the revenues over 10 years. And those revenues I picked up both as broadband and mobile, because a number of these satellite systems are multi-purpose. They do both broadband and mobile. So you need to essentially look at both to offset the cost of the satellite systems. So what you see is that for SpaceX, their 10-year CapEx is something like $45 billion, but their revenues are nearly $100 billion. The majority of that, over something like 85% of which, come from their broadband service. So the service that Dennis talked about earlier, the one with the flat panel dish. The mobile revenue would not by itself justify the cost of the launch of the Starlink system. but nevertheless a good healthy profit over the 10-year period of about $50 billion for that service. Amazon LEO has got pretty much the same capex over time, fewer satellites, but as we noted, higher launch costs, and that leads to $48 billion of capex, but lower revenues, and that's because it's starting from a much lower point. It's a few years behind. It doesn't have the broadband subscribers that Starlink does. It's going to have to grow those, and even if it manages to get to Starlink levels towards the end of the period, clearly for much of the time it will be at a lower level. And similarly, we're assuming that on the mobile side as well, that it only gets a smaller share of the market. Now, these are assumptions made with our best guess, but with no evidence, because we're having to base this on a market and on operators that don't yet exist in most cases. So you can certainly question these assumptions, but again, hopefully it just gives you a feel for how this might play out. But notably for Amazon LEO, they're making a loss, about $23 billion over the 10-year period on the basis of those assumptions. AST have got a $7 billion 10-year capex. We're assuming that they don't offer a broadband service, so they're trying to recoup that entirely on the mobile side. And in fact, they actually managed to do that and make a small profit. Well, small profit of £3 billion, but small by comparison to the others out to the end of that. And the picture, by the way, is one of the AST satellites before it gets put back into concertina, back up, put into the nose cone of a rocket, and then it will unfurl again like that in space. Okay, so I mean, what does that tell us? It tells us that the business case potentially could be profitable, but probably not for all three operators, and certainly not for any more than that. So that's promising. They're not all going to go bankrupt, but it's possible that they may not all be there in 10 years' time. Next slide, please. So let's talk a bit more about spectrum. I mentioned earlier spectrum acquisition and the use of spectrum from mobile operators. And essentially, this is a key choice that the satellite companies have to face. Are they going to use mobile satellite spectrum, MSS spectrum, so spectrum that is designated by the ITU generally globally for satellite use? It's the sort of thing that Inmarsat, Iridium, Globalstar, all those companies have got and been using. Or are they going to use spectrum that's mobile spectrum, MS spectrum, spectrum that is thought of as terrestrial spectrum and owned by the mobile operators? And there's pros and cons to both, as you can imagine. The mobile satellite spectrum is great in that it's available globally, there's no interference. Once a satellite operator has got it, it's free to do what it wants. It doesn't have to pair up with anyone. You can offer a service pretty quickly, just as Apple did with the iPhone. The downside is there's not a lot of it. So the actual amount, the overall absolute amount is relatively small. And the amount that each individual operator can get tends to be of the order of 10, 20 megahertz, typically something like that. Whereas to put it into perspective, the totality of the cellular spectrum that's used terrestrially is about 1 gigahertz. So that moves you towards, why don't you use that? The downside, of course, is that spectrum is owned by someone else, the mobile operators, is used by the mobile operators. It's not sat there doing nothing. And therefore, you have to work with the mobile operators, potentially clear it or find ways to use it in areas where the mobile operators are not using it intensively. And then there's no end of border issues that occur if the same arrangements don't align on the other side of a geographical border. Less of an issue in the US, not too many borders, but a real nightmare in Europe for that space. Now, when we started looking at this, it seemed that the direction of travel was very much to use the mobile operator spectrum. But we then saw SpaceX acquire EchoStar spectrum. We saw Amazon acquire Globalstar for their spectrum. And we've even seen AST acquire some ITU filings, which still got a long way to go to turn into spectrum. But nevertheless, an indication that they're all aiming to get some kind of predominantly MSS spectrum for their own use. Now, that's going to be difficult, it's going to be expensive, it's going to be messy. So we'd expect a whole range of different options going forwards, and potentially different in different countries. The spectrum that SpaceX have got is US spectrum, so that means they can do something different in the US compared to globally. So this whole picture, I think, is a messy one and a difficult one to fully predict. Next slide, please. Okay, so let's now start to address the question that we picked up right at the start of this presentation, which was, could D2D replace terrestrial? And I've got a couple of slides on capacity. So this one is just data that others have thrown out. And then in the next slide, I'll turn to look at some simple analysis that we did ourselves. For example, Nokia have said that the D2D capacity is more than 100 times lower than a rural terrestrial network, and clearly a rural terrestrial network has got much less capacity than a dense urban network. The interesting one, perhaps at the bottom, is T-Mobile's president saying that the use of T-Satellite, so essentially the SpaceX Starlink system, was 0.0002% of total network traffic. Now, that's only a starting point. This is early days for the service. The service could have more capacity in a number of different ways, more spectrum, more power. It's probably not being used very widely because people aren't aware of it. So I don't see that in any way as indicative of the endpoint, but nevertheless, it does set into perspective the enormous difference between what we're currently seeing for satellite capacity and terrestrial capacity. If we jump to the next slide, please. So this is one very simple way to look at it. And being simple, of course, it simplifies many things, but it does, I think, make it intuitively easy to explain. So this is looking at Starlink versus a typical MNO in the US. Starlink have got 65 megahertz. That's the spectrum that they acquired from EchoStar. At the moment, if you look at some data that's been developed by Ookla, a crowdsourced company, they're achieving about 0.8 bits per second per hertz with their actual systems deployed to real handsets. Now, of course, people, when they talk about efficiency, tend to quote much higher numbers, but then the real world intervenes and efficiency drops. And so 0.8 is a real number from real data that's out there at the moment. Their cell size, well, if they do the best they can with a sort of 15-kilometer radius, and that's quite small for their cells, then you end up with a cell size of 700 kilometers squared. So you can just multiply those together and end up with the capacity that you see on the right-hand side. And then you can do the same from an MNO. They tend to deliver about 2 bits per second per hertz. Again, that's might appear a low number. Certainly you can get up to 5 or 6 bits per second per hertz in 3.5 gigahertz if you've got a good quality of signal. So quite conservative. But their cell sizes in dense urban areas and cities can be as small as 1 kilometer squared, or even smaller indeed if they're indoor cells or similar. And that leads to the capacity you can see there. So, I mean, it's a 1 to 10,000 ratio. Now, you could be out by an order of magnitude or two, and that's still an enormous difference in ratio. So, it's pretty clear, I think, that satellites are not going to have the capacity of terrestrial networks. And there's not a lot they can do to change that. They can get better, maybe by a factor of 10 all told, if they get more spectrum, if they have bigger antennas, if they manage to push the power up a bit, but they're certainly not going to get better by a factor of 10,000. So an important point to bear in mind as we go through the last few slides. Next slide, please. So in the book, we weren't certain how things were going to play out. We still aren't certain. So we went down a typical route of a number of different scenarios, and we spent a whole chapter on each of these, explaining what they were and how they would play out, and then trying to justify what we thought was the likelihood of them happening. So the first scenario, MNOs in the driving seat. So essentially that means the MNOs maintain the relationship with the consumer. Essentially, you get your satellite access through your MNO as part of your monthly cellular subscription in just the way that T-Mobile is offering at the moment. So this is kind of the status quo, or at least the clear current sense of direction. And the reason for going down that route is manifold. Mostly it's a spectrum one, but it's also much easier for the satellite operators. They don't have to build billing systems, customer relations systems, all those other kind of things that go with managing a large number of subscribers. The downside is the MNOs keep some percentage of the revenue. We've postulated 50%. Who knows? We're not privy to the actual deals being done. So that percentage could change. That's just a starting number. But we give this a high probability, 80% at least, because it's what's happening at the moment. So it would require some kind of change in direction for that to move away from that. So the second scenario is that change of direction. It's that the satellite network operators win out, that they gain enough spectrum, or they gain some other leverage over the mobile operators that essentially they can now go direct to the consumer. And this could be the case if, as we showed on one of the very early slides, for example, if SpaceX buy T-Mobile in the US, then clearly they are essentially a combined satellite and mobile operator, and they've got direct customer relationships. Now, you could argue actually that's not really the satellite operator winning out, it's kind of a combination of the two, but nevertheless, the satellite operator becomes the brand that the end consumer sees. And clearly it could happen. We think that there's a reasonable probability in specialist areas, so serving oil rigs or something like that, certain niche areas where the capacity needs are relatively low and the willingness to pay is high for true global connectivity. But for general consumers, seems unlikely, predominantly due to the capacity issues that we flagged earlier. It's very hard for the satellite operators to build enough capacity to go very far by themselves. And so they're going to have to be extremely reliant on the mobile operators. And in that case, as we've seen, the mobile operators are not too sure they want to have an overpowering SpaceX taking their customers. And so they probably wouldn't do the kind of deals that the satellite network operators would need to win out. A third option is that the internet service providers, by which we mean entities like Comcast and Charter, predominantly the cable operators, but other similar players too, essentially use all of their in-home and in-office Wi-Fi resources to provide a large data carrying capability. It's of course what you can get already if you sign up to Comcast for a mobile service. And then they use the satellite network operators elsewhere rather than mobile operators. So you could, in principle, bypass the mobile networks altogether with Wi-Fi doing the heavy lifting and satellites picking up the coverage elsewhere. But the capacity needs for that just aren't really there on the satellite side. You'd have to build out pretty extensive Wi-Fi or small cell networks across a lot of areas for that to work. So we give that a pretty low probability. Next slide, please. So here's our predictions. You can see we've divided them up into three areas: what we're pretty sure is going to happen, what we're pretty sure isn't going to happen, and then everything else. We are pretty comfortable that the satellite D2D service will be offered. We're not going to see all these operators go bankrupt and the whole thing get turned off, or there any other kind of situation that causes that to happen. We think there will be competitive provision in the Western world from the companies you see there, and also in China from Chinese companies, and in some places like Africa, they may well choose between them. There may well be competition between both China and the US operators in those kinds of places. And we think capabilities will improve beyond that you currently get from the iPhone to something like a 2G, 3G cellular level. So by that, we expect that you'll be able to have voice calling, reasonably good messaging, reasonably good internet browsing. Unclear whether you'll realistically have video calling. Now, of course, it has been demonstrated. AST can show you video calling over their satellite, but that requires a big chunk of the capacity of a satellite and may not be practical to deliver realistically once the network starts to get loaded. So 2G, 3G, roughly level of service. We don't expect D2D to replace terrestrial networks for the capacity reasons we talked about. We don't expect it to be pretty good, to be of much use indoors. That's because satellites predominantly have a signal coming down vertically, and that's really tough to get into a building. It has to go through the roof, number of floors before it gets to the user. Much easier to come in horizontally as terrestrial systems do, but even then, as we know, terrestrial systems themselves can often struggle in buildings. We don't expect the satellite operators to become the primary owner of a customer relationship unless SpaceX start buying up lots of mobile operators around the world. But even then, it may still be the mobile operator that is the primary owner. And we don't expect D2D to be particularly useful as a backup. It would feel like it is a great backup for cellular systems failing, but unfortunately its capacity is so low that if one of the mobile networks goes down nationwide, it would just completely overwhelm the satellite network, even for the most basic of communications. So it can handle small-scale terrestrial network failure potentially, but not widespread. And then our uncertainties, well, we are uncertain around the business case for the reasons I talked about earlier, that there's just such a lack of knowledge and a lack of prior history to go on for these numbers. So a lot of it really is hand waving. We're uncertain to what extent geopolitics will cause countries to say, well, it's not economic, but we must have our own satellite network, and therefore you get more of a fragmentation. There's also the potential for national regulators to step in and say, for example, that MNOs that have got D2D must do certain things. They must hit certain coverage obligations. They must provide emergency calling for everyone or whatever, which could potentially make some of this either uneconomic or not particularly attractive. So regulation potentially could harm it, or potentially, I suppose, it could favour D2D in some ways by requiring MNOs to use it. And indeed, in Australia, there already is a requirement that the MNOs offer a D2D service in the areas where they don't have coverage. And then finally, the spectrum position is a little uncertain. We've got WRC27 coming up. There's a lot of discussion there about potential new MSS spectrum. There's also some MSS spectrum in Europe coming into play, the S-band and others. So that's all a bit of an uncertain area. Not sufficiently uncertain to stop this service developing, but at least to determine to what extent the satellite operators will be able to do their own thing with their own spectrum, or whether they'll have to go to the MNOs. Next slide, please, which I think is the last one. So, can D2D replace terrestrial cellular? That's the question we ask. I mean, yes, for deeply rural coverage, it already does. And there's no problem there. The capacity is fine because there aren't many people in deeply rural areas. That's a great service, a valuable service, and one that we're delighted to see deployed. It could potentially replace terrestrial cellular if MVNO arrangements are reached. Although it's not really replacing cellular there, it's just owning the customer. The cellular networks are still absolutely required. It's just that they become wholesale networks rather than retail networks. But it certainly isn't going to replace mobile networks. We're not going to see mobile networks turned off because D2D is now available. We might see more Wi-Fi offload or other tactics to try and reduce the reliance on them, but we're absolutely not going to see, I think, material change to those networks in terms of their scope, size, reach, customer numbers, or data that they're actually carrying. And that is the end of our presentation. So hopefully we've now got time left to answer some of the questions that I see we're starting to arrive. So I'll hand it back to, I think, Andy, are you going to manage the question session?
I am going to try. Let me stop sharing, although I may need to call the slides back up at some point if somebody asks questions about that. John, were you monitoring the questions as we were going along? Because I had my screen on the slides.
Yes.
So it might be
Yes.
better if you moderate the questions.
Sure. So I think we'll have time to answer all of the questions that were asked. I'll start with the first one, which is from Faranaz Edelat. I had thought Verizon will also be partnering with AST, but that wasn't listed in the table of mobile operators. Is that not included in the review from mobile usage for AST?
And it actually was on an earlier slide. Perhaps we missed it on the table. I have to go back, but certainly Verizon is connected to AST, as is AT&T, as is Vodafone. They're the lead three who have been not only established a partnership relationship, but who've also directly invested in AST SpaceMobile. So there is a high expectation that they will work together, and it is even possible that T-Mobile would switch, since they are part of the consortium of the three major U.S. carriers that are seeking to harmonize satellites and really build a bit of a wall between their terrestrial properties and the satellites to ensure that some of the things that William talked about do not happen, that the ownership of the customer is retained by the terrestrial operators.
Thanks. And also from Faranaz, how does the D2D satellite transmission, say from AST, used within AT&T's licensing areas not cause interference to the AT&T phones not connected to the satellite within the same area?
William is more rigorously nodding his head than I, so I'll leave it to William.
Yeah, I mean, the really simple answer is that they use different spectrum. So AT&T and other operators will set aside some spectrum for satellite usage. At the moment, for T-Mobile, it's not been very much. It's been 2 by 5 megahertz, but they could make it a larger amount. And essentially, that spectrum is not used for terrestrial communications. Now, you could, of course, make it area specific. So you could say, well, I can carry on using that spectrum for terrestrial communications in cities where the satellite coverage isn't needed, but I won't use it in the rural areas, and then the satellite can use it in the rural areas, and we won't get any interference. And that can work to some degree. The thing to watch there is on the uplink, actually, that you can end up with a satellite seeing uplink from quite a wide area, and if there's millions of users outside of the direct cell, but within a broader area transmitting, that can be a bit difficult. So for the most part, I think operators are dedicating a band of spectrum nationwide for satellite use. Now, of course, that has its own costs. It means the mobile operators can't use that spectrum for their terrestrial network. And that's the reason why it's a relatively small amount of spectrum that's currently dedicated in that space. And I think that's my expectation going forwards, that the operators will be dedicating some spectrum for satellite usage across their network.
And even there, it becomes challenging, particularly at borders. Sometimes in the very place that you would really like to be able to use the satellite service, and in the case of the US, even though, as William pointed out, it's a much easier case than in Europe, but even in the US, the border areas with Mexico, there are large areas that are relatively uninhabited and would be great usage points for using the satellite service. But the spectrum is not necessarily the same on the Mexico side of the border as it is on the US side. And so it has to be handled very, very carefully. And often it says that even though there is the allocation of the spectrum by an AT&T in line with the question, it can't be used in some of the places that you might want to use it, for instance, on the border with Mexico or the border with Canada. And in Europe, it's a nightmare because the cone from the satellite in almost all cases covers multiple countries. The countries are just not large enough there where you are able to contain the cone within the boundaries of the country. So it's a significant challenge.
So let me give an unsolicited plug, because what you just talked about is covered in detail in your book, which I've read end to end and bought. I've read some chapters multiple times. And so today you basically were able to cover just a broad overview, but
Yes.
there is a lot more information packed in that book with hundreds of references, all available for about the cost of an airport latte. So
you're a great salesman for us, John. We appreciate that.
Thank you.
Well, I've read it and I've reread parts of it, and it's really got, like many of the questions that were coming through here, if we don't get to them, they're likely answered in the book. So let me just go on to the next question. We can go a few more minutes, whatever is, 5 or 10 more minutes. We'll get through as many as we can. And then I guess we'll follow up later with any additional. So a question from Hal Gohl. Question about spectrum. Besides the 3 scenarios, what about SNOs leveraging unlicensed spectrum? For example, D2D. Is it feasible? And what are the risks?
Yeah, so the FCC came out with a proposal on this just this week,
Right.
which was sort of breaking news. And it has some detail in it. It talks about the frequency bands that might be allowed, and specifically mentions that they're higher power. I mean, my take is I can't see how it's going to work because there's just going to be so many devices working out there. So particularly on the uplink, if you're a satellite, you're looking down trying to get the signal from one handset, and in your cell you're going to see thousands, if not millions, of other Wi-Fi type devices transmitting away. How are you going to manage to isolate the signal from that one device that you want to hear from the very broad number of other devices? Now, if this is deeply rural, then maybe, but then there's probably not a spectrum challenge in those areas anyway. So it feels to me like a pretty difficult one to bring off. Dennis, you may have other thoughts on this.
Yeah. Well, the FCC, and I think in a certain way that was wise with FCC. FCC said that it was okay to do it, and they didn't change any of the limits that exist in the current one, but said if you can figure out how to do it, have at it, without explaining how that might be possible. So what William has said is the case, but it is also true that especially in areas, the US, Canada, perhaps Russia, and others that have very large land masses with very low population density, that it may be possible to use that capability in those areas. But certainly if you're talking about an urban environment, it's impossible to even consider how that might be feasible, at least for me. But there are those who are talking about it, and some who are talking about it in terms of finding a way to aggregate the signals into a single location and then isolate it, and then be able to communicate with satellites through not the D2D sort of mechanism, but through effectively a concentration point that would pull together the things that are in the terrestrial side and then beam them up and beam them down with a very focused use of the spectrum. But it's a stretch, is I think what both of us would view that one.
So there are a whole bunch of questions on that we did put into the chat, but I think we've sort of covered and answered that topic, because there's a whole lot of other questions in there, and I don't think we'll ever get through all of them, or we'll be here for another hour. But I've been reading them. Let me try to categorize them as best as I can, and I'll pick perhaps the one, or combine a couple that tend to cover the topic. So from Charles Sheehy, we have, what is the likelihood of AST surviving since it is part of the FirstNet plans? And then there's a whole bunch of other questions about E911 and other public safety kind of response situations.
Yeah, I'll jump on that one. I think this is, as you might surmise from some of the things we've said, it's a wonderful opportunity to handle public safety and emergency service kinds of tasks in rural areas that are not otherwise covered. So to me, satellites are a huge and very positive contribution to meeting the needs of public safety in areas that are otherwise not covered. And I think in the case of AT&T and their FirstNet efforts, they've already indicated that this is one of the things that they are looking to use AST for. And this is where AST, with the gigantic satellites and the capabilities that accrue from those giant satellites, giving them the potential of getting at the upper end of the 2G, 3G that William talked about, capabilities, maybe getting some 4G capabilities in rural environments where there are very few users. This is, again, a great application in my mind, for AST and a great opportunity for AT&T with their FirstNet work.
And I'll just build slightly on, I think there's another element to that question, which is how does this play out into E911 emergency calling type regulation and so on? The answer is it's really unclear. So, of course, most cell phone networks require the cell phone operator to carry an emergency call, even if the subscriber doesn't belong to that network. And then there's often regulation around location of the subscriber and other things like that. At the moment, that regulation, as far as I'm aware, doesn't play out directly onto satellites. So it doesn't require, for example, T-Mobile to offer an AT&T customer the access to their through their network to a Starlink satellite if they want to make an emergency call. And indeed, they can't even make a call anyway, really, because it's mostly messaging. But that could come. Regulators could decide that there should be some parallel equivalent to that and put certain obligations on the mobile operators or the satellite operators to carry certain types of traffic in certain ways. And that could get really messy. To understand how that might work, how you get it to the right place. How does the satellite know even where to route it if the satellite's sort of hovering between two countries or whatever, and things like that? There's a whole load of questions there that I think will need to be looked at and answered. To some degree, they were picked up a little bit when the iPhone first started offering the service, but only touched upon. So yeah, some interesting discussions to be had there.
Yeah. And I'll just add one more piece. A lot of our conversation tends to be around the U.S. and a lot of the questions in the U.S. Probably most of the audiences from the U.S. But there are certainly other parts of the world where things like the emergency service is an enormous benefit and disproportionately important to what we have in the U.S. or in Europe. I'm familiar with activities in the Caribbean and Latin America and South America where there are significant satellite-related engagements that are being formed because of the very thing that we're talking about. It's just a huge opportunity there.
All right, Amit Mukhopadhyay asks, you mentioned the MSS spectrum is being explored for the D2D service, but won't that increase the price of the traditional UEs?
Yep, to some degree, if they need extra bands built in. But I mean, we saw that happen with the iPhone. They built in an extra receiver for that service. It's not necessarily that expensive. I think most cell phones have got about 40 different bands in them already, so this makes it 41. It's incrementally not that big a deal. And some of the bands, like L-band, are already used in some, are already available for cellular use in some handsets, even though it's MSS spectrum in other places. So it won't be a lot. I think it won't be too difficult an ask to add that into the handsets.
Right, and this is where the standards come in. I didn't highlight this when I was talking to the standards chart, but the L-band, S-band in particular, where a lot of the MSS spectrum is located, has already been standardized within 3GPP. So because it's standardized, it's also put in Qualcomm chips. So the cost is very, very limited, the additional cost. And all three of the major US-based players are working in that. They found different ways. William highlighted them, but the large acquisition of capability by SpaceX and then Amazon securing Globalstar and securing the Apple as a customer, which was a very big deal for them. But then AST SpaceMobile has established a relationship with the Legato folks as well, and thereby secured spectrum, or in the process of securing that spectrum, 40 megahertz of spectrum in the MSS band, again, that has been standardized by 3GPP. So I think that there's a bit of a bimodal structure here, but each of the three major US players have found an MSS bit of spectrum to fall back on, and that's helpful for them so that they don't have complete dependency on the MNOs for providing their services. And those are globally harmonized, so that's the other huge advantage of MSS. So it's not just a US phenomenon. They can use that spectrum globally, and that's a very big deal, so that they always have the ability to land their spectrum as long as they have established the landing rights with the regulator in the respective countries.
Okay, thanks. I think you've answered this, but just in case there's a nuance to it. So Masood Olfat asks, recently, the FCC chair talked about unlicensed D2D. As for the uplink, it makes sense, but are you aware if they have any technical solution for the downlink unlicensed D2D?
So actually, I think the downlink might be easier.
Because it's the reverse.
because essentially the subscriber then, if they're sufficiently isolated from other users of those frequencies, let's say other Wi-Fi users, because the other Wi-Fi users, let's say, are a mile or two away in a building, then they'll just be able to see the satellite. So the downlink probably could work more easily. It's the uplink, I think, that's where the problems mostly lie.
And it's just because there are so many potential uplinks that they would see from the Earth.
And Arvind Aradhya asks, can you comment a little on the heterogeneity of the spectrum demand in geographically remote areas versus urban areas? In other words, is there really an economic demand for video calling bandwidth from national parks? Is that a reasonable use case? Is there any evidence for build it and they will come, or is that an assumption we're making now?
Oh, that's a tougher one. I mean, my experience is once people get used to taking videos and uploading them to social media sharing, they'll do it wherever they are if they can, including on a plane or whatever. So I can imagine people in national parks wanting to video call their friends and or TikTok something of the view that they can see or whatever. So I can absolutely imagine that the same applications by and large could be used in those areas if there were the bandwidth and the capability to do that. I mean, maybe not.
Yeah, I would agree. In fact, I think the demand, from the demand side, since the national parks have such natural beauty and the animal life and the various unique phenomenon, people would very much like to be able to stream their experience to others, but the capability is not really going to be there for quite some time, and we'll see. Again, this is where AST is working at that because of those gigantic satellites that you saw the picture of. And Starlink is trying to do it in a different way. They're trying to blend multiple satellites so that you get the capacity by virtue of using 3 or 4 satellites and teaming them together. And whether that will really work still remains to be seen. But that's part of what is going on to try to provide that experience, even in national parks and in remote areas and on tribal lands and all the rest.
Hey, John, I was going to take a prerogative to insert one of my own questions here, if I could.
Please.
So you talk in the book, you mentioned it several places in the book that, the uplink link budget is the most challenging because the handsets are relatively low power, don't have directional antennas. Are there technology developments or standards modifications being made to make the uplink a little more reliable? So, for example, if you just want to, be able to communicate with the satellite to tell it that you're there, it seems like you could whatever power limit you have, if you could send it in as narrow of a bandwidth as possible and punch it up above the noise level, those types of things could be effective at getting a signal up to the satellite. Are there standards? Is that part of any of the 3GPP standards or any technology developments, or having better directivity in the antennas and the phone, anything like that coming down the pike?
Not that I'm aware of. I mean, you're absolutely right. You could do a lot of stuff. You could spread the signal as well in order to effectively give you more range out of it. So there's a lot of things that you could do. I'm not deeply involved in the standards activities, so it may be happening and I'm not aware of it, but I haven't heard of anything like that. It would make sense.
No, and you have to remember the challenge here with D2D is, and it's also D2C is more specifically the cellular. D2D is broader, including IoT, but the D2C, talking to cell phones are terrestrial devices, and having been the chief technology officer of Motorola, the goal was to move the cell phones to a point where it just barely worked. and the reason that you do that is because it maximizes the number of people without interfering with one another. So you have the design goal for cell phones that is in opposition to what you would want to do for the satellites. And because of the usage percentage, I think it'll continue to be the case that the devices will be designed for terrestrial use. And if they can use the non-terrestrial, then that so much the better. But I doubt that there's going to be a great deal of design for that. Now, the one place where there might be an exception is with this MSS spectrum, because the MSS spectrum, even though it's standardized for terrestrial use, it is the area where the likelihood, the probability of use in the vertical rather than the horizontal direction is higher. So there may be some accommodations made along the lines that you suggest for the MSS spectrum that is also 3GPP harmonized and is available for terrestrial use, but that would be the place to look for enhancements being made.
Got it. Back to you, John. Thanks.
So maybe let me tag on from Wuri Haspari, who asked, in 3GPP, which maybe you won't be able to answer, but I'll ask the question. There is an ongoing heated discussion on defining TN band for NTN to be used for SCS supplementary coverage from space. Do you think even the standard band definition is supported? Would SCS work well?
I'm not aware in detail of what this is. It sounds like the aim is to try and effectively identify some spectrum that can be used for this. I mean, to some degree, of course, that's what MSS spectrum is already, but maybe identify some terrestrial network spectrum, so some mobile operator spectrum that could be made available on a widespread basis for SCS. And of course, that would overcome the border issues in places like Europe if you had a certain band that everyone could agree. The problem with that is these bands are already in use by mobile operators. And if you just said it's this particular sliver, then you would find that in any one country, that would be one mobile operator that happened to have that band. Are they going to give that up for all the mobile operators to use, or are they the only one that gets the service? So I think there's anything like that is fairly difficult to envisage quite how it might work. But it may be that there's something more going on here that I'm not aware of.
Yeah, I don't have anything to add.
Okay, we do have some still additional questions. Some of them sort of overlap some of the other questions. So there will be maybe parts that you've answered before. One from George Hervala. Can you comment on the power levels needed for the Earth to space link for D2D compared to a satellite user terminal for broadband, e.g. 2 gigahertz versus 14 gigahertz?
Yeah, so I mean, obviously the key difference with broadband is that you have a directional antenna at the user side. So that gives you a lot more gain than you would have from a handset. So you've got whatever it might be, 10, 15 dBs more gain as a result of that flat panel directional antenna. Now, all things being equal, that will mean you'd need less power. But of course, what you tend to use some of that gain for on the broadband side is to run higher modulation levels in order to get the higher data rates, the 100 megabits a second or so that you can get from a Starlink service. So you essentially trade back that gain for higher performance on the downlink, and you end up probably pretty much in the same place by and large in terms of power levels, but you're trading off antenna gain against spectrum efficiency. But those trades can be made differently depending on how the service needs to be configured.
Yeah, the other side is that the channel sizes are bigger too. So going back to Shannon, you've got more bandwidth, so it gives you more capacity. So you've got more bandwidth because of the gain. You get more effective power. So you actually are working on both of the key elements of Shannon. Capacity was both bandwidth and the power over the noise, and you're going to gain with both of those with that flat panel, and you don't have that opportunity with this cell phone. You don't, because of the directionality. You really don't know where this is going to be, where you are pointing the flat panel at a relatively optimized direction in the sky, and so you get basically zero gain out of a device. And if you're holding it with your hand covering it, you may get negative gain actually.
All right, so there are some comments which we'll make available to you that are in the question chat. But I think we've covered all of the question topics that are in there, maybe not by every individual question, but at least by category. So I think probably at this point, I'd like to ask if either of you have any closing comments, and thank you. What a wonderful presentation and a great resource for our audience.
William, first.
Not much I can think of to add, really. Some great questions. Thank you, everyone, for attending and listening through to this. And really helpful as well to see some of the tenor of those questions. And I'm going to do a bit more research on some of the topics that have been raised in some of the questions. So thank you for that.
And I guess the comment from me is that, first of all, thank you to Win Forum for allowing us to be here. John and to Andy, we do appreciate that, and staff behind the scenes who is actually operating the strings that are moving and causing us all to operate. But I do appreciate that. Appreciate the engagement, as the questions would suggest, active engagement in the conversation, and that's what we, William and I, had hoped, and for that matter, John and Andy, had hoped this might be. So really appreciate that high level of interaction. The final comment is that this is a rapidly evolving area. We wrote this book in an interesting fashion. Some of the things were moving as we wrote the book over the 6 months that we spent writing the book, and so we would tag them. Correct this to the latest information just before we put the book up. And some people have remarked on that, gee, that only happened last week and it's in your book. But there was a reason for that, and it made it a particularly interesting book to write. We had a whole section, for instance, on why Globalstar had to be sold and why Amazon versus SpaceX had to buy it. We were, thought that was really insightful information. And then, a month before we released the book, it happened. So it was no longer a very interesting section to the book. We were quite proud of ourselves having had that carefully thought out rationale for why things had to happen, and then they did, but we couldn't take any credit for it because it had already happened. But it was an example of that. But one of the things that we're actually doing, and you're helping us with some of your questions, we would anticipate in a year's time or so needing to put out a second edition, simply because things have moved and we need to capture where they are at that point in time. But again, your questions were helpful in capturing some of the things that we need to add to the book in the second go around. But thank you again. Very much appreciate that.
I'd like to add my thanks to William and Dennis as well. And again, welcome Roberson and Associates as one of the newest members of the Wireless Innovation Forum. I meant to mention that at the very beginning. But yes, this is great. We do not get any cut from the sales of the book, but the book really is good. I highly recommend that that you pick one up if you're interested in the topic area. And it's one of the hottest topic areas in Spectrum right now in wireless innovation. So, and again, thank you, Dennis. Thank you, William.
You're welcome.
Thank you all.
Right. Thank you, everyone. And we'll see you back on the next episode.